This is lesson 7 of chapter 5, and in this lesson that we are going to subtract linear expressions. Essential question we've been dealing with: how can you use numbers and symbols to represent mathematical ideas? In the last lesson, we learned how to add linear expressions. Okay, we represented word problems made into expressions. Okay, and in this lesson, we are going to learn how to subtract linear expressions. So the two objectives that we will be learning here are: I will learn how to model the subtraction of linear expressions using algebra tiles. And the second objective, I will learn to use the additive inverses to subtract linear expressions. Okay, the corresponding standards for this lesson are as follows. They're on the screen. You can look them up, pause them, okay, and look up these standards. So let's go right away to our lesson proper, okay, in terms of subtracting linear expressions. Okay, so when subtracting linear expressions, okay, subtract the like terms, use zero pairs if needed. So what is important here, we need to understand what like terms are, okay, and we know what zero pairs are from our lessons in the past. We know that like terms are terms when your terms have the same variable raised to the same power, and zero pairs are simply a pair of one unit tile and one negative unit tile, or we can have an x tile, a positive x tile, and a negative x tile. These are both zero pairs. So this is a zero pair right here. This is also a zero pair. Okay, so let's take a look at example number 1 and see how this works. So we want to use models to subtract the quantity 6x plus 3 minus the quantity 2x plus 2. So first, let's model 6x plus 3. 6x plus 3 means that there are 6 x's and 3 unit tiles, and that's what we have here. You have 6 x tiles and 3 unit tiles. So we want to subtract 2x tiles and 2 unit tiles. So what do we do there? We simply cross out, okay, the 2x tiles right there, and cross out the 2 unit tiles right there. So what remains will be 1, 2, 3, 4 x tiles, that's why it's 4x, and 1 unit tile, which will be 1. Okay, so there are 4 x tiles and 1 unit tile remaining. So 6x plus 3 minus 2x plus 2 is the same as 4x plus 1. Okay, let's take a look at example number 2. Number 2, it says that the quantity 2x minus 3 minus x minus 2. So again, let's model 2x minus 3. So when we model 2x minus 3, this is how it looks like. You have 2 x's, okay, plus 3 negative unit tiles. So this is the model of 2x minus 3. Again, if you notice that subtraction, the definition, according to the definition of subtraction, 2x minus 3 is the same as 2x plus negative 3. So if we want to subtract x minus 2, so that means we need to get rid of one x tile and two negative x tiles, unit tiles, I'm sorry. This is how it's going to look like. You get rid of one x tile, you get rid of two negative 1 unit tiles, you're left with one x tile, that's x, and negative 1 unit tile. So that becomes x plus negative 1. Again, according to the definition of subtraction, okay, we know that uh, x plus negative 1 is the same as x minus 1. So 2x minus 3 minus the quantity x minus 2 is x minus 1. Okay, do the guided problems and let's see if you understand examples 1 and 2. Let's take a look at example number 3. Again, we are using models for this. So in example number 3, find the quantity negative 2x minus 4 minus 2x. Okay, so again, we model negative 2x minus 4, and this example is a little bit different, and let's find out how it's different. So this is the model of negative 2x. You have negative 2x tiles, and you have negative 4 unit tiles. Okay, so that's the model of negative 2x minus 4, but it's asking us to subtract 2 positive x tiles. So for us to be able to subtract 2 positive x tiles, we need to add 2 positive x tiles. But if you add 2 positive x tiles, it will change the entire thing. So what you want to do, okay, let me read through here first. Since there are no positive x tiles to remove, add 2 zero pairs of x tiles. So that means when you add your positive 2 x tiles, it should come as 0 pairs. Remove the 2 positive x tiles, and this is what I mean. So here you go. This is your 2x right here, and this is your minus 4 right here. And these are the 2 zero pairs that we added. So this x is paired with that negative x. This x is paired with that negative x. Those are your 2 zero pairs. Since you're adding 0, remember the property of the additive identity, when you add 0 to a particular term, it does not change the term, or it does not change the number. The identity of the number remains the same. This holds true as well with 0 pairs. So when we add a 0 pair, we are not changing the identity of the expression. Okay, now we've added our 0 pairs, and we can now remove our 2 positive x tiles. So if we remove our positive x tiles, you notice that we have 1, 2, 3, 4 negative x tiles, and 1, 2, 3, 4 negative unit tiles. So this becomes now negative 4x minus 4. Okay, so this is actually, if you write it out, this is negative 4x at the bottom right here, plus negative 4. Okay, so negative 2x minus 4, quantity minus 2x is simply negative 4x minus 4 according to the definition of subtraction. Okay, do got it, problem C and D. Let's see if you understand example number 3. Now, here's another way of subtracting linear expressions. This time we are not using models. We're using what we call additive inverse, and we need to know what an additive inverse is. So, an additive inverse, okay, is basically the opposite of the number. So when subtracting integers, you add the opposite or the additive inverse. The same process is used when subtracting linear expressions. Again, what is an additive inverse? It's simply the opposite. Okay, so the opposite of the term, the opposite of the expression, is what we call its additive inverse. Okay, good example would be, remember integers, 5, the additive inverse of 5 is negative 5. Okay, that's when you're using integers. If I'm using expressions, x, the additive inverse of x is negative x. If I have x plus 1, for example, the additive inverse of x plus 1, okay, is basically negative x plus 1. Now look very closely. If I use a distributive property, okay, because it is always assumed that there is a 1 there because of the identity property of multiplication. If I distribute my negative 1 to x, and I distribute the negative 1 to positive 1, okay, negative quantity x plus 1, the additive inverse is negative x minus 1. Okay, so these two are the same. Negative quantity x plus 1 is the same as negative x minus 1. Let me give you one more example. If I have, let's say, negative 3x plus 4, if I'm going to get, there's my x. additive inverse of that, this is the negative 3x plus 4. And if I distribute the negative 1, this becomes negative 3x. Okay, sorry, this is already negative. Let me redo that for you. Okay, let's do that again. The negative of negative 3x plus 4. So if I distribute my negative 1, this becomes positive 3x, and this becomes positive 4. Sorry, negative 4. Okay, so this becomes 3x minus 4. These two things again are these two expressions are the same. This expression is the same as this expression. Okay, so that's a little bit of a background of what additive inverses are. Let's take a look at example number 4 and see how that works. Find the quantity 6x minus 5, okay, minus the quantity 3x plus 1. So first we need to arrange them, okay, like terms in columns. So when we arrange like terms in columns, we arrange 6x with 3x and 5 and 1. So this is how it's going to look like. Okay, so we got your 3x plus 1. Now you notice it already became negative 3x minus 1. Again, from the examples that I gave you, okay, they distributed negative 1 to 3x. That's why you have negative 3x, and you have negative 1 times positive 1 will give you negative 1. That's why you have that. Then you simply add them. Remember, when you're subtracting, you are also adding its opposite, which is basically the same thing. So you're adding the opposite, or you're adding the additive inverse. So 6x plus 5 is there, negative 3x minus 1 is down there. Simply add it. 3x plus minus 3x is positive 3x. 5 minus 1, or 5 plus negative 1, is positive 4. So you have 3x plus 4. Okay, let's do another one. Example number 5. Quantity negative 4x minus 7 minus 5x minus the quantity negative 5x minus 2. Again, okay, we're adding the additive inverse of negative 5x plus 2. So we're distributing the negative 1 to negative 5x and negative 2. Okay, so first we put them into columns. We have 4x minus 7. We don't change that. Now the additive inverse of negative 5x minus 2, okay, after we distribute the negative 1, becomes positive 5x, because a negative times a negative is a positive, and negative times another negative is also a positive, so it's 5x plus 2. Add those two, negative 4x plus 5x is x, negative 7 plus 2 will give you 5. Okay, and that's what we got. So again, this one becomes very important. Rewind this video for examples 4 and 5. Okay, if you did not understand it before you do the got it problems E and F. Okay, let's do the last word problem here. A hat store tracks the sale of college and professional team hats for M months. The number of college hats sold is represented by 6M, the quantity 6M, okay, minus 3, sorry, 6M plus 3. The number of professional hats sold is represented by 5M minus 2. So write an expression to show how many more college hats were sold than professional hats. Then evaluate the expression if M equals 10. So two things we need to do here. First, we need to write an expression to show how many more college hats were sold than professional hats. This is clearly a subtraction problem. And from the bottom and the next instruction, that we need to evaluate the expression if M equals 10. So after we find the difference of those two expressions, we will evaluate them and substitute M with 10. Okay? So from here, again, we need to find, okay, 6m plus 3 minus 5m minus 2. Okay, so that's what it means, right? Expression to show how many more college hats were sold than professional hats. So these are your college hats, and these are your professional hats. So we subtract 6m plus m minus 5m minus 2. Again, just like what we did before, we arrange them in columns. And again, we distribute the negative 1 to 5m. This becomes negative 5m. Negative 1 times negative 2 will become positive 2. So the additive inverse will be 5m plus 2. So that's exactly what we are adding here. We're adding negative 5m plus 2. Okay, we know that 6m minus 5m, they're like terms. We know that that's m. 3 plus 2 is 5. So it is, the expression now is m plus 5. So now that we have found our expression, we have answered the first instruction there. We need to substitute the value of m, okay, which is 10, okay. So doing that, we simply do m plus is the same as m, or sorry, 10 plus 5, okay. So if that's the case, okay, 10 plus 5 is 15. So 15 more college team hats were sold. So when we substitute the value of 10 to 5, we end up with 15. And from the problem, 15 more college team hats were sold. Okay, do one more example. Let's see if you understand. Example number 6. Do one. I'll add one got it problem here for the understanding of example 6. And that's the end of our lesson. Thanks for watching.